Hey guys, this video is for Friday. We are going to spend one more e-learning day on negative exponents, and when we get back to class on Monday, we will spend another actual in class talking about this as well. But today we are going to talk about the inverse of the rule that we learned on Thursday. So on Thursday we learned that a to the negative m is the same as 1 over a to the m, and that's applied right here. Today we're going to say, what happens if I have 1 over a to the negative m? What do I do there? Because if I didn't express it well enough in my last video, our goal when we simplify exponential expressions or expressions with exponents in them is we want our final answer, we want our simplified answer to be written with positive exponents only. We want to remove all negative exponents. And when we have 1 over a to the negative m, that is just the same as a to the m. It's kind of the inverse of the other rule. And you can think of this as a to the m over 1, where I'm just flipping the side of the fraction bar in which my base is on to make my exponent positive. So that's all I have to do. If you can think of that fraction bar as kind of a transition zone, that if I move my base above or below it, that makes this exponent positive if it's already negative. Okay, so let's look at some examples, and like I did yesterday, I'm going to be pulling these straight off your assignment. They might not be the exact same, but they're going to be awfully similar. So if I do example 1 right here, and I'm going to zoom in so it's easier for me to write. If I have example 1 and I have something like, say, cm over x to the negative 3, y to the negative 7, to make my exponents positive, all I have to do is flip the side of the fraction bar they're on. So before I get ahead of myself, this is the same as c times m, and x to the negative 3rd times y to the negative 7th. So I really have 4 different terms here. If you can kind of see those 4 different terms. But all I'm worried about are my negative terms. So here's a negative term and here's a negative term. To make these positive, all I have to do is throw them up there. So my final answer would be cm x to the 3rd, y to the 7th. And this is all one big multiplication problem right there. And that would be my answer. All I have to do is change the side of the fraction bar that they are on. That's it. I know it might seem a little more complicated than that, but there is nothing else to it besides that. What if I have something that looks like yesterday, a little review. Say I have 7x to the negative 8th. That is the same as 7 times x to the negative 8th. And I have a negative exponent there for that base, so all I have to do is put that in the denominator, so my answer would be the same as 7 over x to the 8th. And that is my final answer right there, 7 over x to the 8th. Hopefully that's making sense so far. Let's do another example. Let's say I have something like say I have q to the 3rd, r to the negative 4th, over, say, x to the negative 2nd, y to the positive 3rd. So my whole goal here is just to rewrite this with positive exponents only, and I can make it positive by swapping what side of that fraction bar it's on. So I see 2 negative values here. I have a negative 4 as an exponent there and a negative 2. So all that tells me is I'm going to move this one to my numerator, I'm going to move that one to my denominator. So my final answer would be q to the 3rd, and that my q to the 3rd stays because it's positive, over x to the 2nd, fraction bar, my r to the 4th, and my y to the 3rd stays because it's already positive. So if it's already positive, it stays where it's at. Ooh, that's kind of ugly. If it's already positive, it stays where it's at. If it's negative, that's when I flip the side of the fraction bar it's on. That's all I've got to do is just flip the side of the fraction bar it's on. So let's do another one. Let's say I have, like I said, I'm looking straight off your worksheet when I'm doing this, guys. Let's say I give you m a to the negative fourth all over t to the negative fifth h. So step one is to identify my bases that have negative exponents. I have one there. I have one there. To make them positive, I just send them to the other side of that fraction bar. There, like that. So my answer to this would be m t to the fifth. The m stays there because it's positive, and then h, it stays there because it's already positive. A to the fourth, and I'm just going to rewrite that so my letters or my variables are in alphabetical order. And there's that one right there. mt to the fifth over a4 to the h. Let's look at one that looks like this real quick. If I have, say, e to the negative fourth all over g. Step one is to identify my negative exponents, and there's that. So to make that positive, I know I have to send that to my denominator. And when I do that, I will be left with e to the fourth g in my denominator, but I'm left with nothing in my numerator. In order to leave that in a rational form, I need to write that as a 1 there. And that's my answer right there. 1 over e to the fourth g. Let's say I have, that's example 5. Say I do example 6. Say I have, I think you guys have this, negative. I say that, I have no idea if you get this or not. You could be completely lost right now. I'm really hoping that you are not really lost right now. If you do, email me. I am trying my best to do this, guys. I think you'll get it. I really do. Negative 7 q to the negative third s to the fourth. So we look for our exponents are negative, and I have a negative 3 there as an exponent. Yeah, my 7's negative, but it's a coefficient. It doesn't matter if the coefficient's positive or negative. It just stays where it's at. My coefficients are not going to change places. The only thing that will change places are my bases that have negative exponents. I guess I said that my coefficients won't change. If my coefficient has a negative exponent, it'll change. But nothing on today's worksheet has a coefficient that has a negative exponent. So my answer would be negative 7 s to the fourth. They all stay there because they have positive exponents. And then my q to the negative third would go as my denominator because it has a negative exponent. And now it does not. Now it has a positive exponent. Okay. Let's do 2 more, and we'll call it quits. Let's see here, number 7. Let's do, what if I give you 11 x to the negative third y to the sixth all over 4 w to the negative second. So first thing, I look at my coefficients because I have 2 coefficients here, one in my numerator and one in my denominator. There is nothing there that can simplify. So then I look at my negative exponents and find their bases. So I have a negative exponent there. I have a negative exponent there. That tells me they need to swap locations of the fraction bar. So my numerator, I'll be left with 11. I'll have w to the second, y to the sixth, and I will have 4x to the third. And that is the answer to that one right there. Once again, all I'm doing is just flopping the side of the exponent if it's negative on which side of the fraction bar it is located on. All right, and very last one. That took up a little more space. Example number 8. What looks like something I have not covered yet. Covered all that stuff, covered that. The last I could give you, see, could give you some trouble. Maybe something that looks like this: y, or 1 over y to the negative 17th. We'll make it totally different than your homework. I find my negative exponent. There it is. I know I need to flop that to the numerator. Oop, there we go. Oh, maybe. There we go. And so I'd be left with 1 y to the 17th. Well, 1 times y to the 17th is just y to the 17th. So my answer is simply just y to the 17th. That is the same as over 1, but we know in algebra that any number divided by 1 is just itself. So that's kind of redundant to write it that way because I don't need it there. So my answer would just simply be y to the 17th. So hopefully this helps. I will make sure to attach these notes with your assignment. But if you guys have any questions, let me know. Email me, contact me on Canvas. Besides that, I thoroughly look forward to seeing you guys actually in class. It's been over 2 weeks since I've seen you, since I left early Friday, and it is about time we get this train back on its tracks and get chugging along again and get out of here. So I look forward to seeing you guys.